everyone, my name is 3Deity and welcome to today's video. Over a year ago, I uploaded a video titled Ranking All Disasters Worst to Best and Natural Disaster Survival. In this video, there was a comment that always stuck out to me. This comment read, "It might not seem like a lot until you realize that there's a combination of 23 maps and 13 disasters, making there a total of 1,144,066 possible combinations." While this might seem like a ridiculous claim at first based on some of the replies, I think there is actual merit to this. However, as you'll soon find out, this is a little overestimated. For this video, I will use the term scenario to refer to unique disasters and the map combos you can obtain. So for example, if we were to look at the map Coastal Quickstop, a unique scenario would be Coastal Quickstop with a tornado disaster, or a scenario in Coastal Quickstop that has both a tornado and a tsunami. Furthermore, an additional unique scenario, say Sky Tower with a tornado, would be its own scenario apart from Coastal Quickstop because they are on two different maps. I'll use the term combination in reference to how many disasters are present. So now that we got those definitions out of the way, let's attempt to answer how many unique disaster scenarios are there in natural disaster survival. To start off, we need to figure out how many disasters there are in the game. Currently, as of writing the script, there are 13 disasters. Additionally, there are also 23 maps. Naturally, you may think just multiplying the amount of disasters by the amount of maps in the game, which would give us a total of 299 unique scenarios, would be our answer. However, this wouldn't be much of a video if we stopped there. We can actually go further with one of the more underappreciated features in the game, that of course being the weather machine. You see, you can pay to increase the amount of disasters that will be present in the next round by paying a fee. Every additional purchase adds a disaster, with the maximum being 7 disasters present. So with this in mind, we need to figure out in every situation where multiple disasters are present to calculate our total. For a 1 disaster combination, that's easy, as that is the 299 scenarios we calculated earlier. For 2 disaster combinations, it's gonna be a bit more complicated. First, we will want to create a dataset to visualize this more clearly. We have the constant, the map, and the 2 possible scenarios, those being the disasters. If we are solving on a basis per map, we'll want to multiply the combinations with the disasters we can achieve. This will give us our first number of 169. However, this is not correct. We'll want to remove every scenario that is the same, such as fire and fire, because in natural disaster survival, it is code to take a disaster out from the circulation if it had already been chosen. For example, if we pay for 3 disasters, and our first disaster is a blizzard, then for disaster 2, it will take blizzard out of the circulation and pick one of the 12 remaining disasters. So if disaster 2 picked to be a tornado, disaster 3 will take the tornado and the blizzard out of the circulation because those have already been chosen, leaving 11 other possible outcomes. So if we take out the 13 repeat disasters, we'll get down to 156 disasters on a per map basis. However, this still isn't correct. This is because half of these are actually mirrors. For example, if we roll fire and tornado, then tornado and fire, the same event will happen even if it is in a different order. This is sort of similar to how multiplication works, as if we do 3 times 2, we will get 6, and if we do 2 times 3, we will also get 6. This is due to the commutative property, which can be applied to disasters, as both disasters in the same combination, no matter the order, will result in the same outcome. Due to these mirrors including half of all possible disasters, we must divide our total, 156, by 2. This gives us a total of 78 scenarios per map, which can then be multiplied by the amount of maps, 23, and get us a total of 1,794 scenarios for the situations with 2 disasters. You can see with this pattern and for subsequent disasters that will be more complicated to map out. We can use this formula I created, d factorial over s factorial times d minus s factorial times m, to solve this. You see, d represents how many disasters there are, which is 13, s represents how many disaster combinations are possible, which in this case is 2, m represents how many maps there are, which is 23. Additionally, if you aren't familiar with the exclamation mark, or what we as mathematicians call factorials, this is how they work. For a factorial of 5, it would be 1 times 2 times 3 times 4 times 5. This would give us 120. For a factorial of 6, it would be 1 times 2 times 3 times 4 times 5 times 6 and would be 720. Furthermore, if you're a math expert, you may have realized that this represents the combinations formula, which is usually written out like this if we separate the m variable. But we will include that extra variable on the outside to represent our constant in our problem. As you can likely expect, this can cause a compounding effect. So far, with one disaster, we calculated it to be 299 scenarios. With two disasters, we calculated it to be 1,794 scenarios. So if we use our same formula for 3 possible disasters, it would be 6,578 scenarios. For 4 possible disasters, it would be 16,445 scenarios, and so forth. Now, interestingly, is when we get 6 possible disaster combinations. When doing this, we will get 39,468 scenarios. However, if we do 7 possible disaster combinations, which is the highest for this experiment, we will get 39,468 scenarios. Why is this? Why did we get the same number? Well, if we continue to go further, such as 8 disaster combinations, even though this is impossible in-game, we will get 29,601 scenarios. You see, this is actually a case of mathematical symmetry. If we were to draw this out, we would have a binomial distribution, which is where the graph would be bell-shaped and have the y value mirrored itself onto the corresponding x values in regard to whole numbers. Interestingly, if we go to 13 scenarios, we'll have 23 disasters, which, if you remember, that's how many disasters there are currently in the game. As we introduce more disaster combinations, the pool of available disasters shrink, thus reducing the amount of possible scenarios we can obtain. Furthermore, if we were able to have half a disaster in the game, we would see our peak would be at 6.5 disasters, as this is the halfway point of 13. This would turn our graph into a normal distribution because we ignore the whole number limitations of our previous graphic. The more decimals you add, the more detailed the graph will become. However, having a non-integer for the amount of disasters is obviously impossible. Back to our problem. How many scenarios are there in natural disaster survival? To get this, we will use a summation of 1 through 7 to get a total of 133,653 scenarios. So next time you hear someone say that natural disaster survival isn't unique enough, remember that there are currently 133,653 unique scenarios that you can obtain in this game. If you look at the original comment, multiple people were trying to figure this out, but none were able to account for disasters that are repeated, the weather machine's disaster combination limitation, and that as more disasters are used, it will eventually have a reverse compounding effect because of there being fewer disasters available. Hope you all enjoyed this video, and see you all next time.